Good day to you all. Shall we pray? Lord, we pray, we thank your name, we exalt you above all things. We say, as we start this class, Iupac Nomenclature of organic compounds, that you help us to the end product that we might be more closer to you and we might have knowledge about this course and this subject. We say, be exalted. For this name I pray. Amen. Okay, so organic compounds, naming organic compounds. As far back earlier, before the meeting held in 1930, that is year 1930, there are different meetings that has been held though. So as far back as 1930 though, that is after revising the Geneva system, which was developed in 1892. Some compounds such as CH4 was given trivial names such as marsh gas, or sometimes they tend to call it damp fire, like that. But even some examples like C3OH, given some trivial names, they were named like this. Was called wood spirit. Though we are not going to be considering that, so I'm not going to waste time. Now back to, but this method here will be using Iupac Nomenclature. We'll be using Iupac system. Okay, so Iupac stands for International Union of Pure and Applied Chemistry. So there are rules that govern naming compound. Rule number one is that there are rules. Rule number one is that you find the longest chain. You find the longest, that is longest chain. That is rule one. So we have some other rules as well, which is example, the first 10 Alkane Series, which is alkane, methane, ethane. Rule number two is once you find the longest chain, rule two is you do what to name the prefix. So some prefix to the side chain depends on what you have. The prefix include, let's say, CH3, that is ethyl, methyl rather, C2H5, ethyl, C3H8, that is the prefix. Sometimes you can have Br, bromo, you can have chloro, you can have iodo, you can have hydroxy, halogen. And rule 3 is that you do what to specify the position by numbering the carbon atom along the longest chain. So you specify the position of the branch, that is, you can name it 1, 2, 3. Then you can say tri methyl, like that, and you name the compound like that. And rule number 4 is that if there is more than one branch, there, what you do is that you do what to make sure that you add the prefix position branch to it. You will add the name. You know what I'm saying? If there's more than one branch that are present to it, you will add the name and the position, just like I did here. Okay, so that is that. And also the rule number 5 is that if there are two different branches in a compound and you have, maybe you represent them by tetra, tetra like that, quadra like that. Okay, so here we are. Let's see this. So the first 10 series of alkane family is first is alkane. So we have alkane, and this alkane here you have methane. From the alkane formula is CnH2n plus 2. So this is 1 when it is 1, so that will be C1 H, 2 times 1, that is 2, plus 2, that is 4, so that will be CH4. Okay, you get it right. Then methane, ethane, that is C2H4, and this will not be 4, that was 6. Okay, and that is, we have next in propane, C3H8, like we have butane next, that will be C4H10. You see the difference is CH4. You see, If I add CH4 with this, I'm gonna have C2H6. If I add CH4 to this, that will be C3H CH rather. The difference is this CH2 rather. The difference with 2 CH. So if I add 2 here, you see I will have C2, and that'll be 6, because I'm gonna put 2 here, that'll be 2 times 2 4. If it had to be 3 times 2 6 plus 2 8. So it differs with CH2 rather. So if I add 2, you see C2H6, C3H8, C4H10. So you can ask the difference between alkane family. Then you list it down to the first term alkane family. So we're gonna have something like this. And now the beauty of this thing, of this series, this is alkane family. You say Alkane series. From this formula you have this. There is C4, CH4. So that is, you have your single C and H4. Next one, you're gonna have what? You find out that you have CH here. First thing you have here is this is CH4, so it's gonna like this. It is surrounded by 4 hydrogen. Okay, it's very important to surrounded by 4 hydrogen, because that is the valence electron of carbon. So now for ethane, you find out that the next thing it would be is ethane will be covered with CH3. And the next thing you have is attached to it is CH2. You see, CH2 is common. So next one, this one will be what? CH3, CH2. And what do you have next? That will be CH3. How do we get this? Can you get this? This CH what? CH3. What do you have? CH2, CH2, and you have CH3. So you find out that CH3, both beginning and end, and the beginning and the end, both of it are ending with beginning and is ending with CH3 and is beginning with CH3. That is, begins with it. Now this is the cause. If you notice that if I want to draw this, my ethane is 2C. That is 2C. So my hydrogen that must surround it must be 4. So I can't put one hydrogen here because it already has this bond. This is single bond, double bond, triple bond. Okay. So from here you can see I'll be surrounded by minor hydrogen. By default, I'll be surrounded by what? 6 hydrogen. 1, 2, 3, 4, 5, 6. So we see C2H6. So if you have to be C propane, now that'll be C. How many C? C3. That'll be 3C, 1, 2, 3, and I will surround the remaining portion by hydrogen. Okay. So you see, if you count the hydrogen, that'll be 8. So this is using this formula: 1, 2, 3, 4, 5, 6, 7, 8. Like that. For decane, that'll be 10C. So you see. Now let's talk about butane. Butane will as well be like this: C4H10, right? So now you see your naming this compound. First, before talking about the naming of a compound in details, you find out that this is CH3. This is CH2. This is CH2. This is CH3. Do you see? CH3, CH2, CH2, CH3, like that. So that was what I wrote earlier. Okay, so you can solve for, if it to be for ethane now, ethane will just be what? CH3 and C what? CH. That is 1, 2, 1, 2, 3, 1, 2, 3. So ethane will be CH3, CH3. This is first. Now let's reverse this to name this compound. First thing is, in naming compound, you must know the what we call functional group. Functional group are what they are what determine the chemical. They are the one that determine the chemical properties. They determine the family it is. They determine the chemical properties in general. Okay, they tell you where or what will be the name or will be the family that compound comes from. They tell you how, and they tell you what is it. So sometimes also you have homologous series, and this homologous series is a kind of series whereby this other family generates from. So this is the Alkane series. You can see Alkane come from You see, methane comes from alkane, the word ane. Here you can notice ane. You see, ane like that. So this is Alkane series. So you can make use, you can find alkene, alkyne as well. And we'll also be considering that as well. Now, next one we have as well is that we need to know what we call functional group in detail. So if you know what we call functional group, you will not make mistake in naming your compound. So functional group is what determines the chemical properties. It's what tell you in details what is the property of a thing. So functional group is a reactive group in general. Functional group, it is a reactive group attached to a chemical compound which dictates the physical and chemical properties of the molecule. So for example, now functional group is a what? Is a reactive group. This is an alkane family. So this is the functional group in this compound here. You need to know it first, which is what? 1, 2, 3, 4. So 1, 2, 3, 4, right? 1, 2, 3, 4, that is butane. So seeing no external functional group here or any group here, we can say this is what? Ane family. So functional group is a reactive group attached to a chemical compound which dictates the physical and chemical properties. Okay, if I were to do like this double bond, you see, so this is a functional group here, alkane. We'll be considering that as well. Okay, so that is that. And the presence of functional group is very unique. It's very unique. And also, sometimes some compound can contain more than one functional group. We'll be considering different kind of functional group we have, okay, in details. So functional group first we have we'll be considering as well is know this or friend, okay. So having known this, let me just write it because I'm still gonna need this. So before I continue the functional group, you can also name 11. The first that common are the first 10. So let me drill you a bit. If you only get to this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you only need the 11th one, you have it as on the cane. That we see 11 H 24. Or you can say met the cane. So if you don't want to use on the cane, the next thing can be do the cane. So if you don't want to use that, you can make use of this very series family. The most common one or the most very different one, which are not very common popular, is you can use the cane. Like, you know, it's generated from the word methane. So you can say met the cane. The cane. This symbolizes or this signifies you're talking about C11 H24. So if I say what will be the next one? 8 what? 8 the cane. Like that, and you have C12 H26. If I want to go to, let's say I want to go to 15, that what's penta. You can say meta the cane, eta the cane. So you can say penta the cane. C15. If I want to talk about 16, that what's hexa the cane. Okay, C16 H. That is 2, that is 32, and that will be plus 2, 34. Like that, obviously, C15 H32. You see. So now the functional group in this compound is what's ane. Most times they are always situated at the end of naming a compound. Okay, so that is that about that. Now next thing is we're going to consider the functional group in general. Okay, so first thing is we need to know the kind of functional groups we have. So we have a lot of functional groups, organic chemistry is very wide. It's very wide. So the first type we have is alkane family, alkane, which I've talked about, alkane. And this alkane family, you know the formula CnH2n plus 2. And this alkane family has the formula CnH2n plus 2. Or you can simply write it as RH. Now this R symbolizes or it signifies the attachment. Okay, this is the functional group, just H. Okay, in this case. And the name ending in, don't forget, the name ending it can also be OH, rather, that is ane rather. not OH, A. This does not have functional group. We can just say it's just a mere, it just contain hydrocarbon. So next one we have alkene. Alkene. Alkene is, that's its formula CnH2n. You see. Or you can simply write it in a very simple term. You can simply write it as R, and C. R. Okay, but in a very simple term, this just talks about different attachment in it. Like it talks about difference between the double bond. So in a simple term, you can also write it like this. This CnH2n, you don't forget it has double bond in it. So you can simply just write it. It's just like you can write it like this. Just give you a double bond. So this R, the R there can be ane, can be material, can be any function, any attachment, any branch. So the R majorly talks about the branch present inside it. Okay, just the branch there. So and this is C. So you can have the word ending is what's in. Don't forget, these are what determine the functional group. Okay, so next one we have alkyne. Alkyne is CnH2n minus 2. Okay, or you can simply write it like I wrote the R there. You can simply write it as R C triple bond, and you can also have it as well CR. Right. Now let me explain this. The other time I wrote this as R prime, and you have it as C double bond. You have it as well as C R, and you have it as R prime. That is, you have it as single this R. Now this is just a branch. Okay, this is just a branch. Example, if we want to talk about okay, let's say alkane. Now you want to write, let's get example of alkane does not have methane. There's nothing like methane, nothing like methane. No, nothing like that, because it can't be expressed and it does not exist. Simple. So now we can start from ethane. Now ethane, that is ethane, you have it as C2 from this formula, C2H4. Now you see 2 times 2 4, not C2H6, ethane. This is E. Now this ethane here, you can also name it as 1 2. Okay, but because it is in, it has how many H? It has what? 2H. But you know that is double bond already. This is just double bond. This is triple bond. This is single bond. So you have double bond. That is how you have your H as just, you see, 1 2 3 4. So most times you can write like this as well, like this, H. So this is a 10. You get what I'm saying? This is a 10. And now this RR, you see, you can write this RRC. You can see from here, just signify the branches are there. What are the branches here? The branch can be, you can decide to write any branch here, but in this case here, you have just the branch, like you don't have much branch here. So if I decide to write, let me say CH3, or if I, let me say CH3. Now this here can be termed as R. I can write this in as R. I can have here as ordinary R. I can have here as my C double bond. I can also have anything here and I write as R. Okay, like that. So that's what I'm talking about. That is a branch in general. It's just talking about the branch. Same thing like alkyne and like that thereabout. So next one we have, and you know the word, the name ending is what? This is ane. The name ending is what? Ine. The name ending is ane. So next one we have also the alkane. Now alkane is just alide, alkyl, and alkyl is not neither single bond double bond. No, alkyl can just be written as RX. You can call this alide, you can call this alkane, alkanes, and the word ending it can be a and can be or ide. Next one we have alkanol. Alkanols here are very, now here we got a business. Yeah, these are some main functional group. Okay, so this is ROH. This ROH, I'm gonna be drawing the general molecular formula diagram as well. Okay, ROH here, or you can simply say ROH, like you can just write ROH here, but it's best preferred if you put the dash hyphen there to tell you it is what has a branch. So ROH here, this OH is hydroxyl alkanol. You can also call it hydroxyl. Okay, some people call it sometimes to call it, or they call it hydroxy. You can say hydroxy group instead of hydroxy. You can say hydroxy, but I preferred it as alkanol, or you say hydroxy in general. That is ROH. Now this ROH has a name. It has name ending as what? OL. That is all. You see alkanol, alkanol, no, alkanol, or not all. This is just the plural. Alkanol. Now the diagram is this. That is just the molecular diagram of it. So now next thing we have is we have phenol. We have phenol. Now phenol also is just something. You can't say it comes from alkanol, but it has also had the form. It's from functional groups, from all functional group though. Something we have phenol. Now these phenols here is just ring chain like benzene. I'm gonna explain that as well. This is like this, and you have a red circle inside. That's just a single branch, OH. Now this phenol, you see, this is a molecular structural diagram. It's phenol. You can say phenolic hydroxy group, or phenol hydroxy group, and it ends with what? Phenol. You see, the word it ends is what? It has what is the functional group here? All. Okay, but this is just phenol itself. The functional group here is phenol itself. Is the whole phenol. It's just a little special case. So next one we have ether, or you have alkoxyalkane. Alkoxyalkane. Now alkoxyalkanes, they can also be called ether. Here you have it as R, and these are just different branch. It's just a symbol. It's just to signify a different branch. Okay, simply you can just simply write like this. Okay, so the functional group here we have here is ether. Okay, this is ether linkage. So the functional group is not alkane because it is alkoxy, so you can simply call it oxy. Okay, alkoxy, but the functional group here is ether, or you call it either ETHER, or you call it alkoxyalkane. That is the functional group present, the whole functional group present. So next one we'll be considering is this is at the molecular structure. Next thing we have is alkanal. Now alkanals are also called aldehyde. Aldehydes. Now this aldehyde, you have it as just simply ACrCHO. This is the representation. But if you want to draw this is a molecular formula rather. Now if you want to draw the molecular structure for aldehyde is pay attention, is just your R. First thing, your R is a branch. So you need to get how you draw this. It's very simple. You have your carbon. You see, you have your hydrogen. The oxygen there is double bond attached, and you have your hydrogen as single hydrogen, and you have your attachment. Don't forget, this is how the diagram looks like. This is a molecular structural diagram of alkanal. And you also have the name ending it is what? Nal. Okay, so this branch, for example, this branch, if I want to draw this in this, if I want to draw say example of alkane, let's say ethanol. This ethanol, it can also be can also simply write, you know, the branch here is 18 from 18. 18 is what? C2. So but this will not be ethan, it will not be in form of 18, it will be ethyl alkanal. So this will be ethyl. If you remember, ethyl is what? C to H5. So C2H5, that will be C2H5, that is a branch, this, and CH, you see, this is Alkanol. Okay, so this is an example. So you can decide to split this further. You can decide to just say, okay, since C is 2, I can decide to put this here. I can put my H here. You see, I'll still have my H5, 1, 2, 3, 4, 5. So you see, this is the functional group. Okay, this is the functional group. This guy here is the functional group. Don't forget alkali CHO. So when you see the diagram or when you see the molecular structure like this, you know it is alkanal. Sometimes it's not written like. Sometimes it tends to be written like this. You can also write like this. Let's put your CHO like this. Very simple. So like this, like sending from here. So sometimes you might not even decide to write like this. You can even write it like this. You can also write it like this. It's a now. You can write like since it's CH3, CH2, CHO. You see. So this is also ethanol. Also, you can also write it like C2H5, CHO. Yeah, regardless of those, you need to know every of the ways at which it can be written, so that in case you won't be caught off guard. So when I give you the question, okay. So the next one to be considered, or we're gonna consider, is alkanone. Alkanones are also ketone. Alkanone. You can also call it ketone. Here, this particular functional group here is written as just similar to this alkanal, but the difference is that it does not have H, so you can simply write it as RCOR. Okay, and the molecular diagram structure from there. If you know this CO, just like this, you have it as a C. Your O will be the one that governs the double bond attached to oxygen. Then you can have your single R, that is the branch, and this is the first branch. So you can also decide to write, if you put methane here, methyl, that will be methyl. Now if you put that is methyl here, and you put, let's say, ethyl here, you say, okay, let's say you put methyl and you put methyl here, that will be methyl. You get my point? Here will be known. Known will be what governs it. Okay, so let's say, for example, you have methyl. So let's say I have C3CH3. I have my CO, and I have also CH3. So I can simply have what C2H6CO. Okay, and now from here you can name this is ketone. You should know this is a functional group. Okay, that is the functional group there, and this is methyl. So you can simply say methanol methyl. Yeah, but you can say ethanol ethyl or methyl, dependent on the name you have there. So when you talk about functional group or talk about naming compounds, you would be more exposed to it. So next one we consider is alkanoic. Yeah, this is one of a kind of interesting functional group or organic group, reactive group there. So don't forget what is functional group. Functional group is what is a reactive group. Okay, don't forget that. It determines the physical properties in a chemical compound. So next one is alkanoic. Now alkanoic can also be called carboxylic. Carboxylic group. Now it's just RCOOH. I prefer this to be in a compound which is very destructive. I prefer this to be in a compound, but it's because it is one of ones whereby it's very great. If alkanal, alkanol, alkane, alkyne are in a group, and this is in a group as well. You know, functional group can be more than 2 or 3 in a compound. So if this is present, it would swallow all this. So the name at which you name that compound will be based on this. It will end with this. Yeah, I will explain more when we get to sample. So before I clean this, to draw the functional group or to draw the molecular structure rather, is very simple. Your C has double O, so that will be R. You have your C here. And you're gonna have your carbon, you have your double bond attached to this oxygen here. I'm gonna have my single OH here. You see, it has what? Nah, it has all. This is all. It has all. You know what I'm saying? So it is very important. So here it can be branched. You can put ethane here. You can put ethane, ethyl, C2H5. That what? Ethanoic. This will be ethyl, ethanoic, noic. Okay. You can decide to split your C to H5. So next thing we'll be considering is also don't forget the functional group there is OIC, OIC. And next thing we'll also be considering is we'll be considering what we call Alkanamide. Alkanamide, yeah. Or let's consider Alkanoate first, because Alkanoate, let's think about Alkanoate. Yeah, Alkanoate can also be called Ester. This is Ester's esters rather. So the functional group, or if you want to write it out, is also just like your Alkanoic, but that is RCOO R prime. If you remember, what is this RCO? There's a compound that is just RCO R prime. You will get, if you remember, the compound that has RCO R prime is what Alkanone. So if I have my single or zero to it, and like this, that is what Alkanoates. Now this Alkanoid, just the way you draw your Alkanoic, if you remember, Alkanoic is what RCOOH. Okay, so if I change this, in how I draw my this is just your R, you see double bond O, your double bond O, yeah, and you have your particular single bond, that is your OH, and this is it. So I want to draw my Alkanoates, yes, same thing. I just got the split this guy as well. I'm gonna have something like this R, I'll have my C double O, yeah, I'll have my single O, and I'm gonna have my R. This is just about different branches, and you know the extra formula or the functional group there is what's NO8. That is O8. Okay, O8. So next one we'll consider is, now we can consider Alkanamide. Alkanamide also, you can call it amide. And your amide is given as, you have it as RCON NH2. So this RCONH2 is also, you can call it carbamide group, and the molecular diagram or molecular structure formula is your you can have it as R, you can have it as C double bond O, and I'm gonna have my NH2 here as well. Okay, these are very strong functional group. If are present in compound, tend to swallow up the remaining ones. Okay, so amide, and I have my NC. You remember Frederick Euler? Remember that there's a sample of a compound. What he did something like this, NH2. You don't forget, you have your H2N, you have something a group here, you have also have your NH2 here as well, which is your CO. If you don't forget, you have your CO here, you have your NH2. That's a amide. So you can find out that this is ammonium cyanide. So this is just simply what R, CO, what R. Can you see? So in this context, if you remember, the functional group that has RCOR prime is what? Alkanone. Okay, so and that is that. So but that is ammonium cyanide, depending on the compound present in it, because that was not just NH2. That was not H2N rather, or NH2 rather. So Alkanamide, you have this, and the functional group present is what? Amide. It's just amide, and you have your alide RCOX, and you have your RCOX as well. This actually is alkanoil aldehyde. That is, you have it as alkanoil aldehyde. Okay, so yeah, this aldehyde, you have also, when you draw this that will be R, your function, your branch. You're gonna have your carbon here, you're gonna have your double bond present, you're gonna have your X here, like this. Okay, so we also have anhydride, and we have as many as possible. So here we're going to be stopping the functional group here, and now we consider examples of how to name compounds. So having known this, you've done a great job. You've done a lot of jobs. Okay, you've done a lot of great things. So next thing we do is, now we name compound. Okay, so first thing we consider is, you consider the long word chain. You consider the long chain. Okay, you consider the long chain. So for example, if I say name the functional group in before we start naming, name the functional group in, let me say this question 18. Name the functional group in 18. The functional group is very simple, is what? In, right? That is double bond, given as the formula is CnH2n, simple, or you say or R, like just put double bond there. Don't have to waste time. We'll have this. So also you can decide to write this out. Okay, if you want to write this out from the formula, that will be C2. Okay, that will be C what? C2 H what? H4. And if I want to do my function, if I want to do the general molecular formula, I'm gonna have a C here, just my H. You can decide to draw you can draw yours like this. You can draw it like this. You can draw it like this. You can decide to draw it like this. You can draw it like this, but to be double bond. Okay. So next one is let's say name the functional group in also let me say 1,4. Okay, let me give you these examples. 1,4 pentadiene. So these are questions, and now let's name the functional group. Name the functional group, or list the functional groups present in the following organic compound. As you can see here is just diene. This shows it is what? 2 in present in this particular group, but the functional group is just in, that is double bond, simple. Ethanol. The functional group is what? No, that is all. And if you remember, all is what? The attachment, and you're gonna have it as what? ROH. Okay. And you can draw this. You can also name this compound. You can also sketch them out. So let me just push it to out there. Now in naming compound, you find the longest chain. Once you get the longest chain, that is, you want to name it from that general molecular formula to the names like this. But if you want to reverse it back, now from here you want to write the general molecular formula, you need to know the functional group. So the functional group is what's in, that is double bond, right? So here the functional group here is what's in, that is double bond. So the next thing attached to it is the series that carries the functional group, that compound, the length of the carbon. So this is penta. If you remember when I was explaining pentadecane, that is what's decane 5, that is 15. Okay. Now also here is pentadiene. So penta means how many? 5 carbons. 1, 2, 3, 4, 5. 5 carbon. Then diene, that is 1,4 pentadiene. That means this 1,4 there, it signifies that this diene, you see, it corresponds with di. That means it's 2 in present. And also you must pay attention, naming compound, you must pay attention to you putting these appropriate signs there. But I'm going to explain that now. Now you have diene, so that will be 1,4 diene. So I can start anywhere. I can start here or here. Okay, you see what is attached to this carbon is, you see, if you check how they've been attached, this guy is attached like this, attached like this, like this, like this. So we count 1, 2. So let me say 1. This 1 diene is in number 1, so it's also in number 4. 1, 2, 3, 4. 1, 2, 3, 4. You see, so I'm gonna have 1, 2, 3, 4. So I'm gonna have my words 4. Okay, so I come again, I have what? 1, 2, 3, 4. Okay, so that is that about that. Now, and also if you decide to start here as well, you start here 1, 2, 3, 4. You see I have this. Okay, so I have this is 1,4 pentadiene. So again, cover remains with your hydrogen, so you can simply have this guy as this 1, 2. So how many bond remaining? It's just 2. So you can decide to say, okay, 1, 2 here, 1, 2. You can cover 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. You can decide to put it here. You can decide to put it different way so that you can give it some kind of shape. You can decide to put this here. You can decide to make this here. This is a simple one. You can decide to you can prefer to like that. So now we have the structure here. again as what 1,4 pentadiene. 1 2 3 4 5. So I have my, now imagine you're given this compound as a question and you have something like this, and you have some 1 2 3, you have something like this. So now I asked to name this compound. These are hydrogen present there, just hydrogen, 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 here, hydrogen, hydrogen, and you're asked to name this compound. What do you do first? The first thing you do is you consider the functional group, because it determines, it's a reactive group that determines the chemical and physical properties of a chemical compound. So here you see I have that, I have in here, that is in family, and I have in here. So I can just name, considering the longest chain. What is the longest chain possible here? 1 2 3 4 5. 5 is pentane, so I have pent already, and I'm gonna say okay, so is in. Oh, so the in are situated where? 1 2 3 4 5. So the in is situated in number 1, number 4. Okay, so you can also decide to say, if you want to name this compound, if you want to also write it from here, that 1 2 3 4 5. You see, situated in number what? 1 and number 4. Okay, so now 4 5. So you can say okay, therefore this is what? 1 comma, the diene is present what? 4. So if you want to join 2 numbers or 3 numbers or 5 numbers like that together, you know what we need to call we have what we call prefix, we have what we call suffix. Suffix is the shortened form, but is very singular. Example, chloro. You can have prefix, you can add suffix to this, or prefix rather. So if I have this branch here, Cl that I wrote there is just simply the group present there, but the prefix is what? Chloro. That is chloro, while the suffix is chloride. So the suffix is like the full name of the compound. If I write bromo, imagine I put Br here. What is the prefix? The prefix is what? Bromo, BROMO. Why the suffix is what? Bromide. We have iodo, we have also amine. And the range, okay, the range, and they also have their own cadre. And the cadre include you have your chloro, you have your bromo, you have your iodo, you have your amide, like that. So, and also another thing important is that whenever you have these guys in the group, in a functional group or in a group, you need to consider the name at which they fall alphabetically. So that is CB. So here this will come first if there's to be in a compound. Yeah, I'm gonna put this in an example here. So I have chloride. Okay, that is just the suffix and the prefix. Now this is 1,4. And the longest thing is what? 1 2 3 4 5. That is penta. You see, I join in with what? Hyphen. So whenever you want to join numbers together with letters, you join it with hyphen. But when I join 2 or 3 numbers, that'll be 1,4, 5, 3, like that. And this is 1,4 penta. The in there is 2. So that's why I wrote that diene at the front. I did not write it's very bad or not correct if you write 1,4 dipenta in. This is wrong. It's wrong. Why? Why is because if I were to name this compound, or if you're not name this compound based on the Iupac Nomenclature formula and rules, you need to, that means you're saying that penta is what? 2. It's double there. So you're telling us that we have only single words in. Okay, but if you're to consider this here, this guy here, which is 1,4 pentadiene, that means you're saying that in is 2. Other thing is let's say 2,3, 4, like that. It will be tri in. So you can even have on 1,1, 2. You can have like that. You can have 2,3. You can have things like that. Okay, so now also if I were to put, let's say, want to consider a situation whereby we have bromo here. Let me say I have Br, I have Cl, I have my iodo here, that is the diene, and I'll name this compound here. What I'll consider as first is I'll consider my functional group, right, which is what's in diene. Okay, so I have diene present already, and it's situated in number 1,4. Okay, already like that. So next thing I get to consider now is the what about the branch is present there. So the branch is present there. First thing alphabetically is bromine. Don't forget, chlorine, though bromine is stronger than chlorine according to electronegative series, electronegativity. Okay, and chlorine has the highest electronegativity. Okay, so but according to this particular how they decrease according to the group, this is very stronger, and increase according to the group is very stronger. So and this guy is very stronger than, so this is stronger than this is stronger than this, and this is stronger than this. But this guy is stronger than every of them. That is why we call it functional group. So if I name this compound, what will I do first? That will be my alphabetically. If I want to name this first, that will be 1, 2, 3, 4. Or I start from here 1, 2, 3, 4. Okay, so if I start from here 1, 2, 3, 4, I'm gonna have it as you do your numbering based on the closest to the branch. Okay, you do your numbering to the closest branch, to the branch that is very closer, based on the branch that is very closer there. Okay, and so if I want to do this here, I'm gonna have the closest branch here. I can start to name this 1, 2, 3, 4. So if I put this guy here 1, 2, I'm gonna have it as 1. Okay, but because of this guy present in this is very powerful than chlorine. So but this guy is powerful than this. So in this case, I'll put this here 1 because this is more powerful and it's closer. So that will 1, 2, 3, 4, 5. So since 1, 2, 3, 4, 5, I will have it as iodine is number 1, bromine is number 5. So that will be 5. Okay, that is 5 bromo, right? Bromo is number 5. 5 bromo. That is this prefix. I want to confidence in number 4. Hyphen join the letters. 4 chloro is BCl, chloro. Next one, 1 iodo. You see, then I can now join my pentane. That is now if I write this, the next one I didn't write this diene. That will be 1,4 penta diene. You see, so this symbolizes that I named this iodo 1. Why? Because it's very greater in reactivity. In reaction, it's reactive. The reactivity is very greater than this. So it will like swallow up this. Okay, so this brings it. So 1, 2, and I'm having as 5 bromo. Okay, and print it down. You see now that's why I said this is branch. R at the other time that's just branch, and you have your in present. So you see this is a sample of what I wrote that time. C double bond, yeah, and you have your C, you have your R, you have your R. So these are the border. Now let's consider the naming of the functional group. Okay, so now naming this functional group as well. You have what the functional group here is what ethanol. Ethanol here is also what all family. This is a functional group there, and you saw ethane. That is what C2 ethyl C2H5O, because it will be ROH. And how do you know is C2H5 from the word ethane, ethyl. Okay, ethyl here. So let me quickly explain ethyl for you. Okay, so here also from the alkyl family, remember we have alkane. The first 10 series of alkane family is methane, ethane, butane, alkane. Now we have alkane. So if I write alkane, you have your methane, ethane, you have your ethyne, you have your propane, propene, ethane, propene, butane. Also you have your ethyne, you have your ethyne, you have your you have your propine, like that. Now you also have propine, you also have your propyl. That's what I'm saying. So you have your ethyl. This is from the formula CnH2n plus 1. Okay, plus 1, and you have your ethyl, you have your methyl. So methyl is from alkyl formula, and is easily attachable to in iron, and that's the rest functional group. So methyl, and that is the number 1, right? So if I put 1 here, I'll be C1 H2, 2 plus 1 3. It's CH3. If I say ethyl, that'll be C2, 2 times 2, 4 plus 1 is H5. Okay. So, and also you have your propyl, pentyl, propyl, and we say that it differs by, if it's C3 H what 7. It's just odd number. Once you notice odd number, regularity of odd number, that is just E family, E family, alkyl family. So you see it differs by what? CH2 as well. Okay. So then, having understand this now, we can now go therefore to name ethanol. So ethanol is now ethyl all. That is what C2H5OH. This is a functional group. And if you don't forget, want to draw this as well, you should remember it's just simply ROH. Propanone, none. You know what I'm saying? That is own is the functional group there. And if you remember, your own functional group is also RCO. Yeah, propanone R, you have your R branch, and you have your none as CO. Okay, and if you remember also that when I was explaining that you want to make your known family, you gotta understand that it will be RCO R prime. Okay, and this is also ketone. Now in this propanone, it's very simple. That will just be what? Propanone, that is C propane, that is propyl, C3H7. So instead of the 7 there, you're gonna write your own family. Okay, so it's best advisable when you write this. You can just write C3H7. Oh no. It's, since the formula is the functional group is RCOR prime, so that will be best if you write this out. So you have your RCO. If you remember how to draw your functional group of ketone, you have it as RC, and you can have your simple R prime. You have your double bond O here. So I gotta put my C2H5 here. So since single C, I'm gonna put my H. I can put my hydrogen here present. But this will give me Alkanol or Alkanal rather. So I'm very careful with that. C3H7. So C3H7. Okay. And I have my R prime here. Okay. So when I have my R prime here, depending on what it should be H that's present. You can see this. You can say this propanol. So don't make the mistake. Okay. So you can start to split this out and propanone, propyl, C3H thereabout. So now I'm saying here that this is a functional group, which is C3H7 propanone known family. What is the functional group here as well is what? Oic family, RCOOH rather. Oic. This is very simple. You just write your butane there. What is the butane? C4H. This C2H n plus 1, 2n plus 1. So this will be C4H8. That is H9, and you have your O. That is COOH. Thereabout. Okay, you want to write ethanoic, that will be C2H5 COOH like that. And hydroxypropanol. Now hydroxypropanol, don't forget OL, that is the oxyl. Oxyl family is also known as the word drugs, right? And oxyl family is also your like that, and it is a ROH, just like your ethanol. Okay, so that is hydroxy alkanol all family. Now this is all. You can see propanol is most reactive than all, so propanol is a bit more superior to this in a layman language. So propanol is a functional group there. Nal is a functional group, and if you remember, I'm going to draw your null is also RCHO, null. Okay, null. So I'm going to write the K that which the range for you. Yeah, and that is propanol. So from a single bond, is it single bond to double bond to triple bond, so you have your null all family, all to null to oic, and we have the other ones just like that. So this is more superior to your single, like chlorine, bromo, iodo, okay, like that. So like these are the first set, second, third, fourth, fifth, sixth, like that. So this is more superior. If this is present in a group, it will be the functional group. If everything is present in a group, this will be the functional, because it is the highest, the most reactive. Okay, so cyclobutanamide, butanamide is just amine, okay, and the amine, if you don't forget your anamine, okay, I didn't talk about amine, just like amide is your don't forget your RCONH2, but amine here is just simply R, and you have primary amine, secondary amine, NH2, and you have the two dots here on top. That's just amine. Amine is just RNH2. This is just Lewis dot structure. And but if it were to be amide is also CONH2, RCONH2. Okay, that is that. Now let's consider some order, how to now name the compound from the order as spread like that. That is from the non-green down to this state here. So let's consider these few examples. Now you see, nominate compound here, there's no double bond. You see there's double bond here, and these are just very simple. Okay, so shall we name them? First thing is you find the longest chain present. So I haven't found the longest chain. You see, if I find 1, 2, 3, I can decide to say 1, 2, 3. You see, 1, 2, 3. Now this is propane, simple. 1, 2, 3. I found the functional group here is what's just A. There's no, the functional group here is what's in. The functional group here is what's A, because you just have your suffix and the prefix there. So 1, 2, 3. 1, 2, 3. Okay, I can also count it like this. 1, 2, 3. 1, 2, 3. I can also count like this. 1, 2, 3. 1, 2, 3. So there are still 3. And I can't count, you can't just count 1, 2. This is wrong. You need to find the longest chain. So the longest possible chain is either way. So I decide to count 1, 2, 3 here. So if I decide to count 1, 2, 3 here, let's see, 1, 2, 3. So in this context, so I have 1, 2, 3, 1, 2, 3 here. So if I'm going for this straight chain, my branch is what? Here. Okay. So let's say we have 1, 2, 3. Or let's say we have 1, 2, 3. So if I have 1, 2, 3 here, next one I count, naming this compound, I gotta have this is just 1, 2, 3. That is what? Propane. So the functional group is just A. But you see, we have a branch here, number 2. That is what? Methyl. So that will be 2 hyphen to join methyl. Tell me that is methyl. To tell and say it's methyl. So 2 methyl. 1, 2, 3. That's what? Propane. 2 methyl propane. Okay, so we're gonna have 2 methyl propane. 2 methyl propane. Next thing we have as well is say number 2 here. Can you give it a try? We have what? Find the functional group in, and it's double diene, and you're gonna have 1, 2, 3. So let me say I gonna wanna change. Let me say I want to put something here. Let me say I put some bromo, and I put iodo here, or let's say I put methyl here, CH3. So you see, you want to name them what? 1, 2. So here, without putting this, the first instant, this is stand here. This is just simply what? 1, 2, 3. So if I want to name 1, 2, 3, 4, either way, if I name 1, 2, 3, 4, I will still have 1,4. Okay, so if I have 1,4, that is 1, but this is not 4. Okay, that is what? 1, 2, 3. It's not 4, it's 1, 2, 3. So that means that the 3 is in what? Here. And also, if I decide to name it here 1, 2, 3, so I'm saying that this is more preferred, because if you name like this 1, 2, 3, you must be very careful to not get a mistake. So either way, so if I name 1, 2, 3, I have 1, 2, 3. So this is what I can call, you can name it 1, 3, That is 1, 2, 3, 4. But what? Butadiene. Okay? Or more in another more preferred way. Okay, let me write it up there. Or in another way, you can just say buta 1, 2, 3, 1, 3 diene. You see? So each of the way is correct, but comma must be there and hyphen must be appropriately. So now let's give it so name this. So if I want to name this here, find out longest chain is what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I said if I change this as well, so if I change this correspond here to bromo, and let's say here is bromo and here is CH3. What do you find? You find the longest chain. 1, 2, 3, 4. You know, you can say 1, 2, 3, 4. Okay, but don't forget there's carbon here. So you can also extend this guy here and just simply you can see write C and you can write 3 here. Okay, like this, and I'm gonna have so I can have 1, 2, 3, 4, 5. I can have 1, 2, 3, 4. But the longest chain here is what? 1, 2, 3, 4, 5. And you know, if you can count 1, 2, 3, 4, 5. Why? Why is because if you are considering longest chain, you must know what we call numbering. Numbering is C 1, 2, 3, 4, 5. Now the concept of numbering is this: when I go here, I have 5. Now when I'm coming back, I also have what? 1, 2, 3, 4, 5. 3, 4, 5. Now let's go clockwise. That is this direction. Clockwise, the right hand side, the right counting for this numbering gives me the branch I have is in number what? I have the bond in number C. I have it as 1. I have it as 1, 2. So I have the first one. The first one I'm coming here. The first one I have is what's in number 2, and I also have it number what? 4. So I have it 1 plus 4, and that is 5. Now when I'm coming left, that is my left hand side counting or numbering. I have it as the first branch is 1. But here the first branch is not in 1. The first branch is in what? 2. For this, that is what? 1, 2. 2 plus 4, that is 6. Again, I come again. That is what? 2, 3, 4. So if I'm coming left hand side, I have my number as what? 1, and I have it as 1, 2, 3. I have it as 1 plus 3. That is what? That is 1, 2, 3. Okay. So as 1 plus 3, and that is 4. So you pick the lowest numbering. That is why by default you can't count. You can't count it like this and number like this. So you see this 4. So this already cancel this counting to from my right hand side. So the recounting or the renumbering using that Iupac Nomenclature rule will now be I have my hydrogen 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2 here, 1, 2, 3, 4, 1, 2. So I'm gonna have bromo, hydrogen. So I can have what? 1, 2, 3, 4, 5. That is the longest chain, pentane, and I have diene there. Okay, so and I have bromo in number 1, 1, 2. So that is 1, 2, 3, 4, 5. So I can have it as what? Bromo is number 1. That is 1 bromo. Okay, that is 1 bromo. Next one I have as well is hyphen. What is next thing? Oh, I have nothing on there. That is just pentane. That is 1 bromo, 1, 2. So my chain is in what? 1 and 4. 1 bromo, 1, 4 pentadiene, or you can say 1 bromo pen. This 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 penta 1, 3. 1, 3 diene. Okay, so also that is that about that. Now let's consider here as well. If when you consider this, what define longest chain 1, 2, 3, 4, 5, 6. 6, that is hexane. Okay, but you have branches where if you count like it's 1, 2, 3, you find out that the branch is in what? The branch is in number, is the longest chain 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Hexane. We say 1, 2, 3, 4, 5, 6. Okay, so here now we have branch here, we have branch here, we have branch here, but in this case, single chain, bromo is very powerful. Okay, like we said earlier, chloroiodo bromo. So like I said earlier, that your bromo, and in numbering you gotta bring it. So first thing we find is what? 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 5, 6. Okay, so in numbering, and I decided to number it like this because the first branch, this counting from here, will give me the closest branch as what? Bromo, and I have the closest branch as well as what? Iodo, which is also the one of the greatest present in this particular concept here. Okay, so you have your having your iodo here is number 3. Okay, so your iodo here also is very powerful, and it will cancel out this your particular methyl and this as well. Okay, this is methyl is not powerful as iodo, so I'm gonna have 1, 2, 3. That would not be 3, but from the alphabetic naming, that is naming it alphabetically, bromo comes first. 3 bromo. I'm gonna have it as 4 chloro. I'm gonna have it next one as 3 iodo. Continue the naming here, okay? So 3 iodo. I'm gonna have my next one as hyphen, and what? 4 methyl. Now the next is 1, 2, 3, 4, 5, 6. Hexane, 4 methyl hexane. Okay, so that is 4 methyl hexane. That is, you have 3 bromo, 4 chloro, 3 iodo, 4 methyl hexane. Okay, so also some of you have not comment on it. Make sure you drop a comment on a comment in that section for comments there on the channel, and click the like button, and make sure you click the click the bell button to subscribe for more updates. And also if you have someone who wants to join, let them reach me, and click on drop a good comment as well. Good comments as well in the comment section. You click subscribe button as well. This is the link, but you put it in all time so you can get more update that is to the channel. So here let's continue. We have, so now considering these examples also, it's very simple. You can just simply name them as 3-chloro 2-methylpropene. Propene is give it your answers, and there's a correction. So you can find out your chloro, this is a functional group. Propene is just 3, 1, 2, 3, and your propene is 3, and your methyl is number 2. So 1, 2. I have my methyl up here, CH what? 3. I have my chlorine number 3, 1, 2, 3. So my chloro can also be what? Can also be a chloro. Complete the shade 1, 2, 3. This is 3. This is 1, 2 here. 1, 2, 3, 4. This is the diagram, very simple. And imagine you want to draw this out here, and that is just 1, 2, 3, or 1, 2, 3. Now if I see if I see 1, 2, 3, that is very wrong, because in this case 1, 2, 3, if you put your 3 chloropentene here as well, so like 3, but it is in, so you find that the in there, what's the number? This, not prop 1 in, no, not, you can prop 1 in. Prop 1 in is also prop in. Okay, prop 2 in is not propene, it's just prop 2 in, or 2 propene. So now also we have double bond there. So if I name this like 1, 2, 3 is wrong, because it will disregard this answer as prop 3 in, and that is just propane. So it's 1, 2, 3. In another way, you can decide to write it like this. You can say, okay, 2, and you can put your Cl here. You see what? If you put if I put 1 here, that means this guy is 1 here, 2, and you see 1. So that will be prop what? You still give me the same answer. I will still have it as what? 1, 2, 3. So I will still have it as 3 chloro, 2 methyl propane. Okay, so now next one, propane 1, 2, 3 triol. So the functional group here is all, and if you remember, your all family is COH, if you remember, and that is your what? Your OH, and therefore I'm gonna have this propane is propane is what? 3, 1, 2, 3. So I'm gonna have it as 1, 2, 3, and is 1, 2, 3 triol. Triol means all, like you know, all is OH. It's a big one, right? OH. So now that shows that I'm having 3 all there. So it's very simple. You just put it there on each placement at which you have them. So all here simply means I'm gonna have what? All here. Remember, I'm gonna draw this out. Your all is ROH, no other attachments to it. So I'm gonna have my OA, O here, O. I'm gonna have my O. Very simple. That is 1, 2, 3. Or even it means 1, 2, 3, and I have my H attached to it. You have my H, I have my H like this. And I have my hydrogen, I have my hydrogen, I have my hydrogen, 1, 2, 3, hydrogen here as well, hydrogen here, like this as well. So and you have it as well as prop 1, 2, 3. That you can have sample. Another example is that you can have 18 1 all. 18 1 all. You see 18 1, 2 diol. This is 1, 2 that is very simple as well. You just need to what? Just something like this, and you just what? H. That is what 1, 2. Something very simple. Okay. So okay, what about this example? Consider this example. If I have dinoic. So let's say you have ethane dioic acid. Ethane dioic acid is very simple. What do? You just name them. Ethane is what? 2, 1, 2. But you need to know the functional. The functional group is what? Oic, and oic is what? RCOOR. RCOOH rather. You need to know how to draw the molecular structure. The molecular structure is what? R. You have your C, double O, and you have your what? O what? That is OH here. So this diagram here will help you structure this very fine and very well. So I have 2 ethane here, dioic. That means it's 2, and they are both on 1. Okay, that means it's 2, and they are both present on dioic. Okay, so that means we're gonna have ethane and dioic. That means 2 present. So I'm gonna have it as, since this is 1, I'm gonna have it as what? O. You can have your O, and you can have your H here. You can have your H present. Yeah, you can have your O. You can have your O. You can have your H present here. You know what, you can draw it like this in another terms, very simple terms, just very simple. You have here, you have your, as usual, you have your O, you have your O. Your next thing also, you have your O, you have your H, you have this is already 1, 2, 3, 4. 1, 2, 3. Like this is ethane dioic. Okay. So we say propane dioic. Propane dioic is also 3. Just put your O and thereabout. So now next thing we consider is we're considering aminomethane. Now this is aminomethane rather. Aminomethane is also something that is not really hard, but next thing you do is you consider the functional group. The functional group here is what? A. But here we have this as amino. That is amino as amino. So next thing we consider is just, you need to identify your amino is what? R and okay, H2, if you don't forget. So and to draw this out is very simple. Just methane is simple carbon, that's a single atom, single one. And next thing you do is you just identify there. So I'm gonna put my NH2 and I have my H is 2. I have my H is 2. And to identify this amino, I put here amino there, and also amino, and now I have my amino 1, 2, 3, 4. That is just that about that. So now methoxymethane. Methoxymethane is as well alkoxy family, oxy here. I told you for alkoxy family, you gotta have it as well. For alkoxy, you have it as well. Alright, okay. And alkoxy here is just ROR. Okay, so now methoxymethane is very simple as well. What do you do? Methane is what? It's just a very single meaning. It's just a very simple. So methoxymethane. So that is ROR, and I'm gonna have it as what? CH3O, and what? C. Methane is what as well? CH3. You can draw it out like C123O or C12. Just there about there. Okay, that is that. Now also we progress to cyclic and acyclic compound. They are very simple as well. So now in we have what we call cyclic and acyclic. So before I get that, we have what we call cis and trans in naming compound. This cis and trans in naming compound, give it just a prefix. It's just prefix, okay? The same way you have your chloro as Cl, you have your bromo as Br, and you have your bromide chloride. So let's say example, you name this compound cis. So you see, you don't name compound like this cis and trans, they're just prefix, okay? They're included in alkene, that is in the geometric other one. So now you want to name cis 2-dichloroethane. It's just your dichloroethane. Ethane rather. Ethane is 2, 1, 2, okay? And but it's double bond, okay? Since double bond and dichloro, that means chloro is present 2 and is situated what? Number 2, okay? That is situated in number what? That is 6 and 2, right? That is to tell you it is 2, not 2,2. So what do you do next is very simple. I have my chloro here, 1, 2, chloro. So this is to tell you that you have chloro present. But in cis, when you have the branch or the prefix like this, when you have it downward, like when you have it downward in a side, when you have it in a single side pattern, it's called cis. Example, like the way this is now, if I decide to put this guy here and I decide to put something here like this, I decide to put this chlorine here, chloro here, and I have my hydrogen here. This is also what cis, because it is up, they are both on the same side. But if one is here and one is here like this, that is what trans. This is now trans. It's very simple. You just put the trans there at the front to differentiate and to tell that they are both on different side. Okay, this is 2-dichloroethane. Ethane is what? 1, 2. So you have ethane here, 1, 2. You have 2-dichloro. Dichloro there means 2 chlorine. You have 1, and you have trans. So it's different. So consider these compounds and name this compound here. So this example is now number 1, number 2, number 3, number 4. Now these examples here, you see, first thing is what? This is just what? Cis. This is cis, but what? 2 in ow. It's just like this. How many carbon? 1, 2. This is not 1, 2, 3, 4. Very wrong. It's just 1, 2. And this is to tell us is what? Cis. Then you have your hyphen at the front, just like prefix or numbering. Cis hyphen at the front is what's both. But this is 4. Now if you do 1, 2, 3, 4 and you just write butane, is very wrong. But you need to make sure you count this, okay? And that'll be 1, 2, 3, 4. Correct. But you need to make sure you put cis here and you recognize the butane. not branch. So if I will name 1, 2, 3, 4, either way, if I name 1, this is 2, it's telling me this is 2 here. If I name 1, 2, 3, 4, I must make my 2 here, okay? So 1, 2, 3, 4, I'm having the butane is what is 4 butane, right? And the in is work here is the number 2, okay? So that'll be cis but 2 in. Okay, now what about this? What do you do as usual? You know, you've recognized the words in functional group, you count the brain or chain, longest chain 1, 2, 3, 4. If I decide to count here as well, 1, 2, 3, 4, this here will be like this. Okay, same thing. So I'm gonna have this as 1, 2, 3, 4, and this is what trans, because they are in different side. Okay, they are, one is up, one is down. I'm gonna have it as trans what both 2 in. So now look at this example. This example here, you have 1 here, you have these 2 here. So one of the rules that govern this in terms of Iupac Nomenclature, naming organic compound, is that once you have 2 common ones that are on the same side, if I can identify them, that shows that it is what it is a cis already. So like in this example here, particularly in this one here, you have it as what cis. That is cis. Now this is cis to tell us is what acting both here. Next thing you have is like I shall count it, and you find out that is what this is cis here. So if I were to find the longest chain here, what is the longest chain? Let's say 1, 2, 3, 4. No. 1, 2, 3, 4. No. 1, 2, 3, 4. No. 1, 2, 3, 4, 5. Oh, if I count 1, 2, 3, 4, 5. You see, it's correct, but this double bond will fall in number 3. And if it falls in number 3, it's very far from me considering 1, 2, 3, 4, 5. So if I will consider 1, 2, 3, 4, you find the nearest chain, you consider the one's nearest chain. So that is 1, 2. So that means this numbering is out here, and the right numbering will be this, because the 1, 2 is nearer to this guy here. Okay, so and that is to tell me that the name of this compound is cis, and that is pentene, right? Pentene in, and that would give me cis 3. That is the chain here is the number what? The chain here is number 3. That is 1, 2, 3. So you see this is the one holding it here. This is where the chain, this is where the branch is rather. So I'm having that cis 3. Why the 3? Because it is 1, 2, 3. It's the one holding it here. Cis 3. Then I'm gonna have it as cis 3 methyl. Okay. But what happened here is that this is 1, 2, 1, 2, 3, 4, 5 pentene. And this is cis because they are both acting here. And this is number 3 that carries this branch, or that carries this branch rather. This is 1, 2, 3, 4, 5 that carries this branch rather. So 1, 2, 3. So I'm gonna have cis 3, and this is what methyl what pent 2 in, because the in is a number, the 1, 2. So I'm gonna have it as a pen 2 in. So what about in this concept? You see, this is a different word. So you found the longest chain as well. What is the longest chain that is closer to the branch? Is here 1, 2. If I count 1, 2, I'm gonna have it as here. But if I count 1, 2, 3, 4 is wrong because it's very short. 1, 2, 3, 4, 5 is very long, but it's farther to the chain here. So I have 1, 2, 1, 2, 3, 4, 5. So this 2 is the one carrying this, and I'm gonna have that trans because I can identify 2 same that are on what this side and this side, upper trend and down trend. So that will be what trans 3, 1, 2, 3. That is it. That is the branch. 3 methyl pent what? 3 pent 2 in, because the n is what? Number 2. So this is about this. Okay, now we're going to consider acyclic and cyclic compound. Acyclic and cyclic. Now cyclic compounds are compounds that are cycle, they are in a cyclic manner. Okay, so we can have some examples like propane. So now let's see, propane in its own state for acyclic is just propane. That is, example is propane. Propane is what? C3H8, and that is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is number of hydrogens surrounding it. Now cyclic is in a cyclic manner. So this propane example can now be if I would say cyclo. But before bringing this, let me show you example. So let me say I want to put something like this. See this. Now this is a cyclic compound. Just drawing this alone, that is all. Now this is what you count it. You can just pick up any branch. You can pick up any number. 1, 2, 3. You can start say 1, 2, 3. This is what? Cyclo. Okay, that will be cyclo 1, 2, 3 propane. Okay, cyclopropane. So what about if I do like this? OH. That is what? Cyclo. What is now the functional group there? Propanol. Okay, what about if I do RCHO? I do like this. You know, this is what? RCHO, and you can have it as RC. You can have it as O. You can have it as what? H. So in this case here, I'm gonna have this guy or this particular compound as what? Cyclopropanol. Okay, so like that. Now there's very important something you need to pay attention to here. Okay, what about, let's see some few examples. What about if you do something like this? Yeah, this is a compound, but in cyclic manner. Now here is just what? This is a very simple one. You can say cyclo what? 1, 2. Cycloethane. This is just ethane. Okay, cycloethane. Now there are differences between cyclic and membered ring. Now if I put something like this, let's say something example like this. This is a simply cyclobutane. Cyclobutane. But what about if I put something like chlorine here, and I put double bond here, and I also put let me say I put this portion here, I put OH. So in this case, you see, you need to know the functional group. The functional group is what? All, because all is more reactive than double bond. Okay, so and the branch here, the remaining ones are branched automatically when you've defined them and you've taken your functional group. So I gotta count. I'll count from the functional group side to favor it. That is a short numbering, and I'm gonna have it as, if I decide to count 1, 2, 3, 4. Okay, so that is to be very closer to give me propanol or butanol. Okay, not butanol, butanol. So here, having done this as but 1, 1, 2, 3, 4, or 1, 2. If I count here as 1, 2, 3, 4, I'm gonna have this. Okay, if I want to draw this out for clarity, is this 1, 2, 3, 4. 1, 2, 3, 4. That means in number 1, I have all. Next thing is now on this particular place, this one, I still have double bond, right? You see, number 2, number 3, number 4, I have my what? Chloro. This is it. Now this is cyclic, this is acyclic. Okay, you can see, so you can know your number of hydrogen present. This is 1, 2, 3, 4. Okay, so you can see from here you have it as 1, 2, 3, 4, but here you have it as 1, 2, 3. So if you're gonna draw this thing out and you're considering this guy 1, you see 1, this is OH here, and I have this here as a carbon. You have double bond present. You see 1, 2, 3, but you have another one attached to it here. That is your chloro. So chloro here as well is in. You see, if I count here my number 1, 2, 3. My number 3 has only 2. Number 3, 1, 2, 3 has only 2. Number 4 has 1, 2, 3. 1, 2, 3. See 1, 2. You see, so you should see that 1, 2, 3 here shows that there is one missing here. So you should be very, very careful in. So don't misconcept it by trying to blend it and bring it like this. Okay, you would misconcept that. So rather just learn it from naming this compound here. So what do you do? It's already what? 1, 2, 3, 4. You should not wonder, you should not matter about the amount of hydrogen present there. Okay, but you can also find it. The amount of hydrogen present here is not the same thing as acyclic. That's why it is cyclic. So here is 1, 2. It's meaning how many hydrogen? 2. It's meaning 1, 2. It's meaning what? Single hydrogen here. It's meaning single hydrogen here. It's meaning 1, 2, 3. It's meaning what? 1 hydrogen. 1, 2, 3, 4. Correct. No hydrogen here. So therefore, you want to name this. Now, what I just did now, if I do like this and I clean this and I do like this, I put this hydrogen here. I put these two guys here like this. I put a single hydrogen here. This is what this is called. This is called a membered ring. Cyclic, a membered ring. Okay, when you show your hydrogen there present. But okay, now coming back to the question. Yeah, I have a question. I have something like this. So in this case here, it's very simple. What you do is just count 1, 3, 4, and that is butane, right? That is butane. Okay, but that is cyclobutane, right? Because of the cyclic manner, and all is present there. So I get to count 1, 2, 3, 4. But I will count in such a way that to favor this double bond and this guy here. Because after this is this, after this is this. So that will be 1, 2, 3, 4. And my 4 for chloro, that is what? 4 chloro. Next thing, I have my what? Is the number 2, right? 1, 2. That means this 2 is 1 carrying the double bond. 1, 2. 2, 2 in 1, 2, 3, 4. Cyclo butanol. Okay, so now also you can name this compound and you can write it out as a normal acyclic form. Okay, so let's see these few examples. Consider these few examples. Now this example is also the same thing as you drawing this. Okay, and you have your H, 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 yeah, you have your O. So you see, so here's what cyclo pentanol. Okay, it's just 1. So cyclopentanol 1, 2, 3, 4, 5. That is 5 pentanol. Now see this example about this. Just put something here. Let's say I put CH. You have CH3 here. You have CH. What did you just count so fast? 1, 2, 3, 4. But you count in such a way to favor the branch. Okay, so you have 1, 2, 3. If you count 1, 2, 3, 4, 5, it's very far. 1, 2, 3. So that was 1, 3 dimethyl cyclo what? Cyclo 1, 2, 3, 4, 5, 6. Cyclohexane. Okay, so what about I have something like this and I have COOH? This is what? Very simple. This is just what? Cyclo 1, 2, 3. Okay, propanoic acid. Some prefer, you can also write it like you can call it cyclopropan, that is propane carboxylic acid. It's also because propanoic is also called carboxylic. Alright, so now we'll be considering double bond equivalent. And before we talk about double bond equivalence, we consider what we call the molecular formula, empirical formula. Empirical formula, it is also the formula that talks about it's a formula of a compound that gives the ratio of the number of different atoms contained in the compound. For example, now ethanoic acid CH2O. This is what empirical formula, because it tells you, it gives you the ratio of the number of different atoms contained in the compound. You see, carbon is what? 1, hydrogen 2, oxygen 1. But what about molecular formula? Example, this is empirical formula is also this is the empirical formula of glucose. If I multiply this by 6, or if I multiply this by let me say I change this to 6, I'm gonna have something like I will have this as C6H what? H12O6. And I can, if I multiply by 2, I can also have it as C2H4O2. So this is the molecular formula. Molecular formula of a compound gives the total number, that is the total number of the different elements. The total number of the different elements present in a molecule of the compound. Okay, so it gives the total number. Why this gives what? The ratio of the number of different atoms contained in the compound. You can see this is empirical formula, molecular formula. So here I'm gonna have carbon as what? 6. Equal to carbon is 6, hydrogen is 4, oxygen is what? 2. So now this coming to structure from now, I'll talk about that. And now to determine the molecular formula of a compound, having an empirical formula of this, or if you want to determine the empirical formula of a compound, first thing is you want to determine the empirical formula of this compound, that is CH2O. So see a question. The question says that determine the molecular formula of a compound having empirical formula of this. Okay, you just consider this example. See, determine the molecular formula of a compound having an empirical formula. Empirical formula CH2O and the molecular weight of 60, whereby carbon is it. So what you do next is very simple. You write solution and yourself. So you remember, empirical formula gives the number of ratio of the different atoms contained in the compound. So the empirical weight you're given is 60, right? So you want molecular weight, right? So to calculate the empirical weight, you can call it the molar mass. Okay, to calculate empirical weight, simply it can just be called empirical weight or molar mass. That is a molar mass. Empirical weight can now be of empirical weight of CH2O will now be equal to your carbon is 12, right? That will be 12 times 1. It has 1, and then plus your hydrogen is what? 1 times 2 plus your oxygen, that is 16 times what 1, and you're gonna have it as everything will be equal to 12 plus 2 plus 16, that'll be 14, that'll be 30. So this is the empirical weight, and so molecular formula for this CH2O. So now, since you're given the molecular weight of 60, next thing you do is you write it out. CH2O as what? N, subscript N, okay, equals to what? 60. That is total weight. So next thing you do is you can do what you, since you find the molecular weight, that will be what? 30N, right? So you can have it as 30N equals to 60. So your N equals to 60 over 30, and that will be equals to what? 2. So here the difference between the empirical weight is that the molecular weight is twice of this empirical weight given as 60. So here we cannot find that the molecular weight or the molecular formula will not be CH2ON, that is 2, and that will be C2H4O4, C2H4O2 rather. So this is the molecular formula of the compound. Okay, so also example, consider this example like this. Yeah, look at this question, something like this. Yeah, this kind of simple question is very simple. And what do you just count? You just count 1, 2, 3. But you know this double bond, and this is oic. Okay, you know how is that you can find out that this double bond. Okay, if I write C, I have double bond. I have O. So, and if you know, you have this is not like rather, you have what? If you have 5 of the formulas, you have is 1, 2, 3, 4. I can have my carbon here, I can have my hydrogen here, I can have 1, 2, 3, 4, hydrogen, 1, 2, 3, 4, hydrogen here. So you see, this is CHO. You should know that this is RCHO. So simply this kind of compound will be what? 1, this is CHO, and you can have 1, 2. So that'll be 2, and that'll be ether. CHO is what? Ethanol. Okay, because here will be single carbon and you have double bond. Okay, so I gotta have this, and I'm gonna have this circle here. It's very simple. Okay, so like that. And also here and talking about double bond equivalence. Double bond equivalence is DBE